everyone, welcome to this video. In this video we'll be solving this question which states that in a group Z, which is the group of integers under the operation of multiplication, right? You know what is this? Z under the under the operation of addition is a group, right? This is a group, this is given to us. Now in this group they are saying what is a subgroup which is generated by 8 and 14, right? So in the first case we will be talking about a subgroup which is generated by 8 and 14. What does it mean? It means that it will contain all the multiples of 8, all the multiples of n, right, where m and n both are integers, and they would also have some power, some common members. Here what do you mean by 8m? It would be 8, 8 plus 8, 8 plus 8 plus 8, and so on, like this. Why? Because the operation here is addition. And similarly for 14n, correct? 14n, we have this thing here, correct? And moreover we also have the elements which are produced by a combination of 8 and 14. For example, you have 8 plus 8 minus 14, which is what? It is equal to 16 minus 14, which is 2. So that means, you see, we also have 2 present within this. We also would have 4 present within it. How? 8 plus 8 plus 8 is 24. 24 minus 14 is what? It is equal to 24 minus 28, which is minus 4. So you see minus 4 is also present here. So that means we have all the elements present here which are multiples, which are common divisors of 8 and 14. So I am answering this question. By answering this question only, can we find an integer k such that this subgroup which is generated by 2 members is now represented just by a single member? The answer is yes. We can write it like this. So let me tell you first of all for the D part. For the D part, if you have m and n as 2 numbers generating this subgroup, right, so you can write it as some number, subgroup generated by k, where what is this k? Where k is the HCF of the numbers m and n, correct? So if this is the case, therefore in the first case the subgroup which is generated by 8 and 14 would be that generated by 2, right? Where what is where 2 is the HCF of the numbers 8 and 14. Similarly for the others, we would have the same case. You can also write it like this, that the subgroup generated by 8 and 14 is what? 2 times of Z, correct? This is another notation. Okay, for the second part we have the subgroup generated by 8 and 13. So for 8 and 13 you can write it like this, because the GCD or the HCF of 8 and 13 is 1, right? So this is generated by 1, HCF of 8 and 13. So you can write 8 and 13 as that generated by Z only, correct? This is Z only. What about C part? In C part we have 6 and 15, right? So you can write it as generated by 3, right? Where what is 3? How we obtain this 3? 3 is the HCF of the members 6 and 15, right? For the E part we have the subgroup which is generated by these 3 members 12, 18 and 45. So you see what is the HCF here? Here the HCF of 12, 18 and 45 is again 3, right? So it is generated by 3, where 3 is the HCF of these 3 numbers, correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.